Alright, so we're going to take a look at how to solve stoichiometry problems for reactions and solutions. I've got two different substances here. I've got a solution of lead nitrate and a solution of sodium sulfate that we're going to combine. And this particular reaction is going to form a precipitate, and that precipitate is going to be lead sulfate. So I'm going to quickly write out the net ionic equation for this particular reaction. It looks a little bit like this. Now you've got lead, which is a 2+ charge, that's aqueous. Alright, that's being added to sulfate, 2 negative charge, that is also aqueous. And then on the opposite side of the equation here, you're ending up with the lead sulfate precipitate. Alright, now the question is, how much of the lead sulfate, so how much of this material am I going to gain by doing this particular reaction? Alright, so let's move on to the next slide. First thing that I did there is I wrote the net ionic equation, so I see what's going on. So I've got lead ions and sulfate ions that are combining to form lead sulfate. This is a little bit different from past stoichiometry because we have wrote out the entire equation. And here, I don't really have to do that. And the reason why is because it is those two ions, specifically lead and sulfate, that will contribute to my precipitate. The nitrate and the sodium will not contribute anything to the precipitate. Alright, so let's calculate the moles of reactants first, because this is a stoichiometry problem in which I'm giving you information about both reactants, so it's a good chance that this is going to involve a limiting reactant. So I'm going to just start with the lead. We told you that there was 1.25 liters of lead solution, and the molarity of that solution was 0.05, sorry, let me erase that. Here we go. 0.0500 molar, so moles per liter. All right, and that, remember, is of the Pb2+. Okay. Now you might say, well, wait a minute, that was for the lead nitrate. But remember, it's going to be exactly the same for the lead because the mole ratios between lead nitrate and lead when placed into water is 1:1. So that means the molarity will also be the same. Alright, so if we calculate this out, we notice that we've got 0.0625. And that's moles of lead. Alright, let's go ahead and do the same thing now for the sodium sulfate. For the sulfate, which is the important part again. We've got 2 liters of that solution, and let's go ahead and multiply that by the molarity of that particular solution, 0.0250. Liters will cancel out. Always cancel out your units, right? Makes things easier. And that's some pretty easy math. That just comes out to 0.0500 moles of the sulfate ion. Alright, now we got to determine which is limiting, right? So if you look back at the net ionic equation from the previous slide, you would have seen that, well, these two things react in a 1:1 ratio, 1 lead to 1 sulfate, okay? So that means it's a simple problem for you now. All you've got to do is look at those calculated moles that you've come up with and say, okay, well, which one is smaller? That's the one I don't have a lot of, and in this case, that's going to be your sulfate. So my sulfate is going to be my limiting reactant. Okay. So from that, we're going to be able to calculate the number of moles of product. So let me start out again with that sulfate, 0.05. That's SO4, 2 negative. Okay, that's moles again. That's moles of that. Right, we got to give a mole-to-mole ratio to get on the opposite side. So for every 1 mole of PbSO4 produced, it'll take 1 mole of SO4. Okay, let's get these guys to go away. There we go, there we go. So we got moles of lead sulfate. And now we have to convert to grams of product because that is what the question had asked us. So we'll need the molar mass of lead sulfate. It's pretty big. Lead is pretty big, so it's 303.0 0.3 grams per mole. Go ahead, oh, I'm sorry, breaking my own rules here. Okay, 1 unit per side of your ratio here. Okay, and then let's go ahead and mathematically do that out, and we should come out with about 15.2 with correct sig figs grams of lead sulfate to be our answer. All right, so the only real difference here is the idea of understanding how to work with molarities, and then also using that net ionic equation to make things go a little bit smoother.